Hey gang, welcome back to Inverted Pursuits Laboratory. And this week in HPR Design Principles, we're going to go over powder charges for your dual deploy so that you can figure out what you need in your ejection force on your rocket. So if we jump into this, first thing is we use 4FG black powder. That is either denoted with 4 uppercase F's and a lowercase g, or the number 4, an uppercase F and a lowercase g. That's just the way they tend to denote it, and that's what you'll find when you're looking for it. When it comes to what you'll need to separate it, you have to go off the amount of pressure that's needed, and that is based off the volume of the tube and the number of shear pins, and volume is calculated by pi times the diameter squared times the length of your chamber. And shear pin force, that can be found usually by what the material is and what it breaks off at, but it usually tends to be a fairly minuscule number. But to figure this out, I ended up making a tool called Powder Calc. A link for it's in the description below, but we're going to jump to it real quick here and take a look at it. Alright, so this is Powder Calc. Powder Calc can be found at jboyson.com/powder-calc. It is a tool I made for the purposes of calculating the mass of powder needed for your ejection charges. So you start off with your 4 inputs: your body diameter in inches, your body tube length in inches, and your pressure in psi. I even denote that this is the pressure used to separate rocket sections. And the mass of the powder as an output has the denote of what type of black powder is used. We also have an output in pound force. So you enter your initial needs up here and you get out a mass of powder. Now this is actually what I flew on my level 2 here. It's the standard thing that shows up the moment you open it is actually my level 2. It's 4-inch body diameter, 10 inches in length, and I wanted 10 psi to separate it. So for that I needed about 5/8 grams of black powder, and it produced 126 pounds of force. I ended up flying it off 1 gram, and that worked really well for me. I just threw in a little bit of extra just to be sure, make sure it blew it apart. But you can enter in the body diameter section, you can enter anything up to 20 inches. If you try to enter anything over, it just goes back to 20. And on body tube length, you can enter literally as large a number as you want. There's no limit on it. Oh, I guess, sorry, I forgot there's a 10,000 limit. But it's shouldn't ever need to go that high. Your pressure, you can go up to, usually you don't need more than 30 psi. 15 is pretty standard. And 10 will do most smaller rockets. But these are your inputs and these are your outputs. Now this is actually based off the NACA powder calculator. I found it a little bit into me writing this web page, but I'll go ahead and show you that real quick as well. So this is the Delaney NACA ejection charge calculator, and it asks for the same 3 inputs and gives the same 2 outputs. So I like this one for that time when you're out in the field, you have no internet connection, and you just have this on your laptop and you can just use it. Mine I find a little more handy when I can just pull out my phone, open up Powder Calc on the web page because I have internet, and I can just quickly do it. I don't have to go into my computer and run it off this. Off this Delaney NACA one, but it's all up to personal preference. I just find this much more handy on my phone, but it's a tool that's there for you guys to use, and that's really what I want to do, is provide you guys a tool that's helpful. So thanks for watching, guys. I hope you enjoyed this content, and please consider subscribing to take a look at more content that I'll have in high-powered rocketry or rocketry in general coming out over the coming months and years. I hope to create an extensive catalog of high-powered rocketry knowledge for people to be able to rapidly access and learn whatever they may be needing. So keep an eye out for more as I continue making these videos, and thanks for watching.